Hi, my name is Kitchun. Today, I will explain why semiconductor chips matter, how the advanced chip storage is connected to sustainability, and what governments and industry can do to build a supply chain that is both more resilient and more sustainable. Let me start with the basics. A semiconductor is a material, such as silicon, whose electrical conductivity can be controlled. A chip is an integrated circuit built using semiconductor material. It can process, store, or transmit information. Advanced chips are especially important because they provide this high computing performance needed for AI, data centers, advanced communications, and modern vehicles. This is why a shortage of advanced chips is difficult to solve quickly. Their productions depend on highly specialized factories, equipment, skill, and supply network. Chips matter far beyond phones and computers. They are the foundation of the digital economy and many modern industrial systems. AI, automations, electric vehicles, medical equipment, and energy technologies all depend on them. This means semiconductor supply has economic, technological, and strategic importance. When chip supply fails, the effects does not stay inside the semiconductor industry. It spread into many other sectors. This is why government increasingly treat semiconductor capability as part of economic resilience and national security. The 2020 to 2022 shortage showed this vulnerability clearly. COVID-19 disrupted factories and global logistics. At the same time, demand increased for the computers, communications equipment, and other electronics. Many industries also rely heavily on lean, just-in-time supply system, so there was little buffer when disruptions occur. But I don't think COVID-19 alone explained the problem. The pandemic was the trigger. The deeper weakness was a highly specialized and concentrated supply chain with limited redundancy. Once one important part slowed down, the impact traveled through the whole system. The semiconductor chain is global, but it is not evenly distributed. Different stages are concentrated in a small number of countries and companies. Advanced manufacturing is particularly difficult to duplicate because new fabs require huge investment, specialized equipment, and technical knowledge. This creates single point of failure. A disruption caused by geopolitical tensions, a natural disaster, cyber attack, or infrastructure problem can affect customers far beyond the locations. So resilience is not only about producing more chips, it is also about reducing excessive dependence on a small number of critical nodes. This is where the shortage becomes a sustainability issue. Economically, unstable chip supply threatens industries that depend on reliable access to technology. Environmentally, advanced fabrication requires large amounts of electricity, ultra-pure water, chemicals, and materials. This is also a social dimension. Shortage can stop productions and affect workers, but the sharper issue for this talk is the paradox itself. But there is also a sustainability paradox. We need advanced chips for AI, electric vehicles, smart grids, renewable energy systems, and more efficient industrial processes. At the same time, producing more advanced chips can increase energy use, water demand, and environmental pressure. So simply saying build more fabs is not enough. In my view, the real sustainability question is how can we expand semiconductor capacity without solving one supply chain problem by creating another environmental problem? Government can respond through three principles: diversify, buffer, and decarbonize. First, diversify. The goal should not be to move dependence from one country to another. Governments should support complementary capacity across several regions. Second, buffer. For critical applications, targeted inventories, multi-sourcing and better supply chains visibility can reduce the weakness of pure just-in-time system. I would avoid treating general stockpiling as only one answer because chips can become technologically obsolete. Third, decarbonize. This is where I think sustainable development policy can go further. Government already use subsidies and tax incentives to attract semiconductor investment. I propose adding green conditionality. If public money supports a new fabs, part of the support should depend on measurable renewable energy use, water recycling, emission reductions, and responsible environmental management. Public policy should reward resilient capacity, not capacity alone. Industry has to convert policy into operational performance. Manufacturers can improve energy efficiency in both chips design and fabrications. Fabs can increase renewable or lower carbon electricity use and invest in water recovery system because water security is becoming a major operational issue. Stronger waste and chemical management also matters as manufacturing expands. Technology can improve resilience too. Better forecasting and end-to-end supply chains visibility can identify shortage earlier. Company can also qualify alternative suppliers instead of depending on one single source for critical material or components. The important point is that sustainable manufacturing and supply chain resilience should be designed together. A factory that is environmentally efficient but still depends on one critical supplier is not fully resilient, and a resilient factory with very high environmental impact is not fully sustainable. I also want to challenge the idea that every country should become fully self-sufficient. Full self-sufficiency sounds secure, but building the whole semiconductor value chains domestically is extremely expensive and can duplicate capacity inefficiently. A more realistic model is diversified regional specializations. Countries develop complementary strengths so the global system has alternatives without every country trying to do everything. Malaysia is a useful example. It already has an established role in assembly, testing, and packaging, with Penang as a major electrical and electronic hub. Malaysia's national semiconductor strategy now aims to move further up the value chain, including wafer fabrications, advanced packaging, and semiconductor equipment, with a target of at least 500 billion in investment. From an industrial perspective, I think this creates both opportunity and responsibility. Moving into more complex processes means high technical and resources demand. Investment therefore has to be matched with stronger environmental, safety, talent and operational standards. That is how Malaysia can contribute to global diversifications without simply creating a new concentration risk. To conclude, advanced chips are foundational to modern economics and to manufacture technology needed for sustainable development. The region shortage exposes a structural problem. Too much dependence on a small number of critical locations and too little redundancy. However, more production alone is not the answer. Policy determines where new capacity grow, while technology and operational practice determine how sustainably the capacity grow. My view is that resilience should not be measured by the number of new fabs we build. It should be measured by whether we reduce geographic dependency without creating new environmental dependency. The strongest approach is therefore to diversify capacity, build sensible buffers, and make sustainability standards part of the semiconductor expansion from the beginning. Thank you.